So it's not just about we need batteries so we can have more solar, although that is true. We need more, even if we didn't install another solar panel after today, we would still need batteries for the grid of tomorrow to meet the needs of what society is asking of it. I think that's an important thing to distinguish. And while I think batteries are important so we can install more solar, they do a lot more than that.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Today on the Clean Power Hour, energy storage. My guest is Shawn Shaw. He is the author of a great book called Energy Storage Systems. Check it out by the ICC, the International Code Council. And I believe you have a new edition of that, Shawn, coming out, but you're also the founder and CEO of Camelot Energy Group. You're a consultant to the solar and storage industry. You're a trainer, and I'm just thrilled to be having this conversation. Welcome to the Clean Power Hour.
That's great, Tim. Thanks for having me.
And thank you, Dave Beavers, for introducing us. Dave is a colleague of mine, and apparently you guys work together, so thank you. That's how this works. If you know of a great guy or gal, I'm always looking for female guests, but Shawn is a great guy. But if you know somebody who you think would make a great guest, not an ordinary guest, but a great guest, please let me know. Reach out to me. I'm easy to find on LinkedIn or at my website, cleanpowerhour.com. And with that, Shawn, tell us a little bit about yourself. How did you get interested in solar and storage?
Oh, that's great. I don't know how far back we want to go, but I let's just say I've been interested in environmental stewardship and protection activities since I was about 4 years old, because my mother was a giant hippie and got me started at an early age. But then I realized pretty early on that I'm a terrible biologist. So inspired by shows like Star Trek and wanting to make a better world, I said, okay, well, environment, physics, that brings me to energy. And so pretty early on, I zeroed in that what I wanted to do was work on cleaning up our energy use and giving the world a little bit more of a runway to figure itself out by using clean energy technologies. So I've been doing this sort of thing, consulting in the solar and storage space for like 22 years, which makes me feel a little old, but here we are. And in that time, I've had the chance to work all over the world, work for government agencies, work on some of the biggest energy storage projects in the world. Everything from gigawatt hour scale systems down to off-grid islands that were powered with some of the early lead acid battery technologies. So it's really been a wild ride, and I'm so privileged to do it. And finally, in 2022, after working at places like Clean Power, Natural Power and Clean Energy Associates, I said, boy, I better hang out my own shingle because I have a very particular mission that I wanna fulfill. So Camelot's goal is to power a just and sustainable society with clean energy. That's it. It's not very complicated, but it's certainly difficult.
A sustainable
And
Jetson society. Okay. So
yeah,
flying
yeah,
flying cars in the whole nine yards, right?
you betcha. Only with solar power though.
Yeah.
They can only fly for a very short time. Um,
Well, we
so,
get
so yeah,
10,000 times more energy than we need, Sean. So actually, if we could figure out how to capture the photons are super abundant.
that's
Um,
true.
the system to capture and space-based solar, you see how even now tech companies are talking about space-based data centers. The prediction on the street is within 5 years that will be cost competitive. We'll see. Only time will tell. They got to bring down the cost of doing the heavy lift to the sky, right?
Yeah.
That's the expensive part. But then you get 6x maybe more insulation, kWh per kWp. I mean, there's a lot less resistance in space to
Hmm.
photons. So anyway, I you
So
know
the future may be within our grasp, Tim.
the future is either very bright or very dark, and who knows? So I choose to think it could be very bright, and here we go. Like I am also on that mission, right, to create a clean energy future, and we have to acknowledge that net zeroing the grid is very good and important, but it's not the end all and be all. We also have to suck the trillion tons of legacy carbon out of the atmosphere. Biology is the key to that. I also am a
Mhm.
biologist originally, and phytoplankton are very powerful only because they are very numerous and the ocean is very vast. But
Yep.
so microgrids and batteries, it's 2026. It's this is the year of storage and microgrids if 2025 was not. And of course, we're only getting started with these technologies. I will also put a pin in. John Weaver and I reported last Friday, Sean, on our biweekly live, that in December of 2025, China installed 65 gigawatt hours of storage in 1 month. That
Yeah.
is more than we installed in all of 2025, which is maybe 40 to 50 gigawatt hours. And that is a national security thing as well. We need
Hmm.
more storage, solar and wind and storage. We also pointed out that there is a lot of fake news about clean energy coming from
Yep.
certain people in Washington. Donald Trump said in the public sphere that China doesn't use wind power. And then we put on screen an image of all the wind farms that dot the coast. The entire coast of China is covered with wind farms. So, what should we
Yep.
talk about next? How should we slice this up?
Oh boy, that's quite a cake to slice. So I guess first and foremost, I think one of the things that I like to kind of set the tone is obviously like Tim, you and I, we are clean energy folks. Like we think solar is reasonably good. We think it's important. But I think it's important to point out for those who unfortunately choose to politicize energy and what we do with it, it's important to draw the distinction that energy storage is a grid resource. It's not a generation capacity. It's really not green, so to speak, in any way.
Right.
It's just like a transformer is not green or a substation is not green. Yes, you might have a substation that you need in order to interconnect a wind farm, but you need substations for a lot of things. And I think storage has an analog there. We don't need more storage just because we want to install more solar. We need more storage because loads are more dynamic. We need more storage because people are demanding a 24/7 constant online presence wherein they can talk to their refrigerators. That all requires data centers. That all requires a very controllable power system. And loads have been very variable for a long time, but they've never been as variable as they are today. So it's not just about we need batteries so we can have more solar, although that is true. We need more, even if we didn't install another solar panel after today, we would still need batteries for the grid of tomorrow to meet the needs of what society is asking of it. I think that's an important thing to distinguish. And while I think batteries are important so we can install more solar, they do a lot more than that.
Yeah, and batteries, I mean, storage, there are many ways to store energy. The Earth's
Mhm.
core is a storage device, right? We have a molten core. It's very hot. If you go a mile down anywhere on Earth, you can have all the geothermal power you want. It's
Sure.
basically
Hmm.
an endless source. It's kind of the inverse of the sun. Um, you can use pumped hydro. You can use compressed air. You can use compressed CO2. You can
Yep.
use hydrogen, et cetera, et cetera, et cetera. But here we are in 2026. There is a couple, or are a couple of dominant technologies, lithium ion batteries
Hmm.
being one. Sodium's coming. The claims, you see the rollout of the claims. It's getting more cost effective and space efficient, blah, blah, blah. So I don't
Yep.
doubt that there's a there. CATL is going hard after that.
Hmm.
And the but batteries, if you're a grid operator, okay, whether or not you care about the environment, right? A grid operator loves batteries because they're very fast and they're two-way, right? They absorb
Hmm.
and they release energy. And and that's what a grid operator needs to balance the grid, right? The
Yep.
loads are dynamic. When America wakes up, the load increases, and then when America goes to bed, the load decreases. And in the middle of the day, we have all this cheap renewable energy available, and batteries are great to store that and kind of level that out and chop the head off the duck, so to speak. So they're here to stay, whether or not we incentivize them. Oh, the other important data point I think is that right now, okay, Mark Jacobson from Stanford just wrote a paper that says we're on track to green our grid by 2148. 100 years later than China. China is on track to green their grid by 2050, and we're on track basically for 2150. And so, if you're a grid operator, though, Shawn, how do you think you see this phenomenon of solar, wind, and batteries? And why do some grid operators embrace these technologies and some really kind of push back and make it difficult for energy developers?
Yeah. No, it's a great question, and there's a lot of misinformation out there. So one of the things I often push back against a little bit is when folks characterize renewable energy sources like wind and solar as unreliable. Technically speaking, they're not unreliable at all. They have availabilities averaging from 97 to 99.5%, and they're predictable to a high degree of accuracy as much as 24 hours ahead of time. And the baseline, when you compare that to the availability of combined cycle natural gas plants, that's a very favorable availability. And so while it is true that this you don't generate solar electricity at night, the important thing for many grid operators isn't necessarily having the power available, but having the power available predictably. So knowing that the sun is going to go down at a precise time and the what the generation of your solar fleet will be at that time
Right.
allows you to more efficiently operate the rest of the grid. So, the concept of we require a lot of backup fossil generation for each new megawatt of solar, those claims are largely overblown. And to the extent we do add storage to these resources, we've seen each of the major grid operators recognize the capacity dispatchability of hybrid projects involving both solar and storage. So, for example, if a grid operator says, well, a 100 kilowatt solar project will only get about 10 kilowatts of capacity credit because I know some days are going to be cloudy when I need that power, adding batteries to it allows you to get, if not that full 100 kilowatts of credit, at least a lot more of it. So by adding batteries to my system or to my existing renewable generation facilities, as a grid operator, I now have a lot more controllability than before. And as you said, Tim, like a battery is two-way. Sometimes I don't want to add more generation to the grid. I actually want to pull generation off the grid. When I have, sort of negative pricing events or really low pricing events at particular nodes, I might want to absorb that excess power and bring it back out later when the pricing is more favorable. So we see folks that own solar facilities in Southern California, for example, having their plant output curtailed 15, 16% of the time. And they're seriously considering if I add a battery, instead of just flat out curtailing and losing that revenue, can I grab it back? So batteries have a lot of advantages to the folks that own the generation assets. But as a grid operator, you can use batteries to control your frequency. You can use batteries to control your voltage. You can use batteries to absorb excess load or generation and therefore offset, costly upgrades and things like that. That's been a Non-wires alternatives have been a utility mandate in many areas for quite some time now. There's quite a lot that you can do with it, and some of the folks that we work with, utilities, have taken batteries and co-located them right near their substations in order to take advantage of some of those capabilities. So there's really a lot you can do with it that you just can't do with anything else. And the important thing to bear in mind here is this isn't even about gas versus solar or wind. We are building gas in the US electrical system. We are already building as much gas as we possibly can. Now, I don't love that idea, but it's a reality. So the fact that we've enacted policies that make it more difficult to install solar and wind doesn't mean we'll install gas instead. It merely means that all energy is getting more expensive for everyone. So we need, I hate to say all of the above, but that's the only sensible solution to meet our something like 2% per year projected demand growth that we're facing now.
Yeah, the grid is changing now. There's this explosion of data centers and electrification. It's a combination of things. And while we may not be leaning hard into electrification of transportation at this moment, it will come back. The economics will drive electrification of transportation. People want what is most cost effective. And once robo-taxis take off, people want transportation as a service. I love being driven around by a driver, and driverless car sounds lovely to me. As long as it's affordable and safe, I'm all in. And it
At
will
least they won't
come.
have the wrong music on.
Oh, so let's talk about microgrids, though. I am a huge fan of community scale microgrids. They don't get talked about a lot, but these are microgrids that can power a small city or a campus, and they're a win-win because it gives the community resiliency. It gives the community the ability to isolate from the grid if there's a wider grid outage and have solar, wind, batteries powering their community. And the hurricane or tornado or fire or earthquake or whatever it is that has affected the area doesn't have to mean they don't have any sense of the good life. And the grid operator, who has a cost plus model, they want to build infrastructure, traditionally transmission and distribution. Well, they have the win of still installing infrastructure. It's just a different type of infrastructure that gives this flexibility to the community. And so it is a win-win. And they've done this. Clean Coalition has done many projects in California, but also here in the Midwest, in Ann Arbor, Michigan. And I just see the writing on the wall that this is going to be very interesting to communities and cities around the country once they start to realize that, oh, this is now economical for us to engage with. So what do you see, though? You work with a lot of developers and EPCs, and I guess we should probably set the table a little more. What exactly are the services that you provide?
Sure. Yeah, so a lot of the clients that come to Camelot for help are folks that are willing to invest in clean energy systems or technologies but perhaps lack the construction or the technical expertise to make that happen or to minimize the risks when it does happen. So we do things like owner's engineering, technical due diligence. We do market analyses on battery systems for folks. And we help commission batteries. We've just recently commissioned about 1.2 gigawatt hours of energy storage projects between the US and Canada in the last few months of 2025. So, we're essentially there to be the technical experts in the corner of the folks putting their money and their livelihoods on the line to invest in a clean energy future. So that's essentially it. It's largely technical in nature, but there's also a lot of logistics and contracts and project management that goes into that kind of thing. So it varies a bit, but it's never boring work, I'll say that.
And so, as somebody who does market analysis, where are the markets? Because like solar is geographic, storage is geographic. We see a lot of utility storage in Texas. We see a lot of storage happening in New York and Massachusetts and now Illinois. Mm-hmm. And California historically was the big dog, but the other states are coming on. What other markets are hot right now?
Yeah, no, I mean you've named quite a few of them that I think are worth spending a minute on. So the Northeast has become pretty hot and is starting to be open for business in terms of larger scale energy storage. So in Massachusetts, under the SMART program, for example, we saw a lot of PV systems coupled with energy storage under SMART and SMART 2.0 because there were adders to have the batteries. But those tended to be very small systems that had minimal interaction with the wholesale markets in ISO New England. But since then, especially with Massachusetts' recent 83E procurement and some other things, there's a lot more interest in larger scale storage and standalone storage here in the Northeast than perhaps there was a couple of years ago. Likewise, when you look at New York has had a rough go with energy storage in many ways. They've been trying to come to grips with it for years now, and I've been lucky enough to be involved in New York energy storage for a long time. And really, like some of the things that they've come out with, Veeder was a big help for smaller scale systems. The index storage credit is a powerful tool for bigger systems. There's a lot of potential, I think, in those projects. And historically, the Northeast has had to rely heavily on natural gas. And to kind of go circle back to one of our earlier pieces of the conversation, I always think it's important to realize that when you're thinking about the effectiveness of storage and the effectiveness of renewable energy sources, the baseline isn't a perfectly functional grid that never has any problems and everything goes easily.
Mm-hmm.
Natural gas, for example, as a generation source requires a very complex real-time supply chain to be perfectly functional. There's never, almost never on-site storage at gas power plants to buffer any hiccups in the pipeline system and whatnot. So while it is, I think it's important to recognize that all generation sources have some nuances that have to be worked around. Some of those generation sources we've spent the last 100 years working out the kinks, and some are relatively new at scale. So, those are all important markets. Texas is a really interesting one, though. And we've had the pleasure of working on a lot of projects in Texas, sort of Texas tens as they're called, plus, some of the bigger ones. It's a tough market. It used to be a few years ago, anybody anywhere could do a nice project in Texas and they thought they would do well at it. We were helping one of our clients with due diligence on a very large developer acquisition, and they had a heavy Texas portfolio. And there were the base assumptions that they were trying to use suggested that all of the projects in the portfolio were going to be great. And because they were taking an overly broad analysis of sort of the ERCOT-wide economics on average, but the variability when you drill down to the nodal level was incredibly high. We saw swings in potential revenue by upwards of 50% from that sort of statewide average of their portfolio. So Texas is okay, but it's super specific and you've really got to get down to the nodal level. And a lot of folks have learned just how shallow ancillary service markets can be because it doesn't take many megawatts to absorb all of the opportunities for something like frequency regulation. Really what you want to make sure you have when you're assessing your project is you want to make sure you have a good fundamental spread in your energy arbitrage opportunity, because that buy low, sell high energy market piece is a very hard, it's not a shallow market, it's usually a very deep market. So it's something that you can rely on. And if you can get ancillary services, great, that's not a bad thing. But folks that are banking their entire revenue stack on these ancillary services, especially a couple years ago in Texas, have had a bit of a rude awakening because everyone else caught on and also moved into Texas.
Hmm.
So you got to watch out for revenue streams that are sort of self-cannibalizing as the storage industry becomes victims of our own success.
Right. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. So we're touching on this value stack. I like the frame that Intelligent Generation uses: earn, save, protect. You were referring to earning with arbitrage and ancillary services, save with arbitrage or attacking capacity charges and demand charges, right? You're reducing your energy bill with with a battery, and then protecting with resiliency if you can isolate from the grid and give some semblance of operation in microgrid mode. So
Yeah, and I feel badly. We sort of skipped over your microgrid question, but it's a really good one, I think, Tim. Um, we don't see a lot of developers taking microgrids and resilience seriously outside of some pretty narrow applications. The DoD has specific resiliency targets and goals, obviously, for their facilities. Data centers have very strict resilience requirements. Any kind of financial processing center has very strict resilience requirements. And in an industrial setting, it can be easy-ish to quantify what the cost of downtime is. If I have a factory that I know produces goods and I make $1 million an hour that it's operating, I know that if I can bring the system, if I can save an hour of downtime by installing a battery, then I can run numbers on how cost effective that can be. But when you're talking about a community center in upstate New York or a fire station in Western Massachusetts, it can become a little more difficult to quantify the value of that resilience, right?
absolutely. And this is one of the reasons why it really is deep water when you're trying to model the value of resiliency. The example I like to give my clients is if you run a injection molding facility and you have brownouts or blackouts, that can be very costly. It causes what's called an uncontrolled shutdown of the equipment. And then the equipment's all gummed up, and that, one example I've heard, it's a local factory here in MISO in central Illinois. The cost was $50,000 per uncontrolled shutdown. And so a battery, even though you're not going to get hours and hours of off-grid operation, the battery gives enough ride through, they call it, to do a controlled shutdown. So, but let's talk about larger microgrids, and why do you think, even though I painted a rosy picture for the utility and for the community, kind of there's carrots for both sides, why are they still relatively nascent? And is it just that they're just bubbling to the surface and utilities see microgrids as pilot projects, not really as robust infrastructure?
It's a great question. I think you're right in that a lot of utilities do still feel like microgrids are in the pilot phase. And various public agencies from Oregon to Massachusetts periodically come out with initiatives to support microgrids. And if you talk to microgrid developers, one of the things that they have a really hard time with is making the financial case for it, because it does cost more to have a microgrid that is truly controlling itself. But when we look at the attachment rate of storage to solar, which is, basically how often out of out of 100 solar projects, how many have storage attached to them? In a few years ago when I looked at this, it was like 4 or 5%. Now, especially in some areas, it's 80 or 90%. And I think that's building up a little bit more appreciation and understanding for how critical even nanogrids can be. And when you're looking at, when you're looking across a larger campus or a larger utility area, having a microgrid in that area, I think utilities are beginning to see the value of that energy resilience, especially as we move from sort of climate change prevention into the mindset of climate change adaptation. More forward-looking utilities, especially in coastal areas, are seeing the value of hardening their infrastructure against weather-related failures and things of that sort. So I think we're beginning to see more interest in microgrids. I think the technology has come a long way in recent years. So I have high hopes that we're going to see more microgrids. But I think one of the big things that might drive it is how terrible, and I'm sorry if you have any utility folks listening in on this, but how terrible the utility interconnection process is. It's pretty bad. Some ISOs and some utilities are worse than others, but fundamentally, there's not enough interconnection capacity available in a reasonable time frame to the folks that want to develop projects. You can have the expertise, you can have the money, you can have the site, and the whole thing comes to a grinding halt because the utility says, not so fast, we need 3 years to study this.
Yeah, and this goes for power plants and for large load centers like data centers, right? Which is why Google just bought Intersect Power. That was announced, I think, in December. That transaction hasn't officially closed yet. It's a process, but anyway, I don't doubt that that's going to go forward. And as we were discussing, they really wanted the dev team, that expertise, to go out there and do large-scale wind, solar, battery projects. And Google, of course, is building data centers or leasing data centers, and they need power. They need interconnection, but they can avoid the interconnection, right, by building a microgrid and self-powering for a period of time. Eventually, they need that grid, but they could get there a lot faster in terms of up and running, right, by building a solar farm and a battery farm, which they could do in a couple of years, and bada bing, bada boom.
Well, and or they can request or require from the utility a smaller interconnection potentially. Right. If you have a 100 megawatt facility that maybe can cover, 80 or 90 megawatts through a various combination of on-site resources, maybe they don't need a 100 megawatt connection to the grid, and that can be implemented much, much sooner too. We saw this as a little bit of a canary in the coal mine as folks were trying to deploy EV charging stations. So one of the big barriers, especially in urban areas, to installing more charging stations has always been getting interconnection for the charging station because the loads could be very significant at peak usage periods. And it took forever. So we saw folks who would literally stand up solar and battery systems with no grid connection whatsoever. You plop it in a parking lot, there's no utility involvement whatsoever. And we're talking to folks now who are even considering, taking a parcel of land, putting solar, putting batteries, and generating, say, green hydrogen at that facility. Again, no grid interconnection to be had. So almost, by keeping our processes as difficult as they are, utilities are almost driving folks to be a little bit more open-minded about microgrid style projects that could pop up anywhere with minimal oversight in that regard. So
Absolutely.
I don't think they're gonna like that, but they'll do it to themselves.
And one of my first guests that brought up this concept of running facilities with large off-grid energy facilities was Rondo Power.
Mhm.
And Rondo makes a hot brick battery energy storage solution. John O'Donnell is the CEO. Check that
Mhm.
out, episode 105. And I was just kind of like mind blown. I'm just like, oh my goodness, yeah, you build this huge brick, hot brick factory that is connected to an energy production facility. The bricks are just the storage device. You need production from solar, wind, one of the two, or geothermal, or a grid, or whatever, right? But he's part of the energy transition and sees himself in that role. All right, so we know technologically this is totally feasible. And just go to Hawaii, right? I mean, go to any island nation or island state, right? Puerto Rico, they have a grid. They are a microgrid in and of themselves. Puerto Rico is not connected yet with an undersea cable to Florida. It certainly could be. It's not that far away. And we are doing that as well. Like in Australia and Northern Africa, they are building these huge power plants and then putting a big high voltage DC cable under the ocean to Asia or to Europe. Going to see more of that. But here in America, I'm very interested in having community scale resilience. And for one, I don't think a lot of energy professionals really yet are aware that this is a thing,
Mhm.
and it's available. But with shows like mine and Suncast and so many others, right? We're getting the word out about this, and so there is a
Mhm.
growing awareness. And I think that the utility model is going to come to a breaking point, and companies and developers will defect if the utilities don't play ball eventually. And now that we have the cost adoption curve, right, of cheaper batteries, that gives us the power to potentially do that. And of course, grid defection scares the bejesus out of utility operators, right? They do
Yep.
not want that because that is life threatening
Mhm.
if large numbers of off-takers have the ability. And so at some point, I think we will get a more flexible grid industry. It's just, it's ironic, Shawn. We built this thing, this machine that was there to serve us with 24/7 power. We did a very good job, except when it comes to modifying the grid and how it responds to new technology, right? It's not very good. That system is just it's not built for change.
Yeah.
So how do you see the role of energy professionals? This is developers and asset owners and installers and consultants like yourself.
Yeah, I mean, I think we as an industry, broadly speaking, have a really important role to play in the grid of the future. Um, there on for better or worse, in the US, our markets are fragmented such that, accomplishing very large national scale transmission infrastructure projects and that sort of thing is very, very difficult. Maybe impossible under the present circumstances, but at the very least, it's quite difficult. And that says to me that what we really need to be doing is we need to be having local distributed energy resources. And it's going to take all of those folks you mentioned to make that a reality. I think the utilities are coming along. I mean, as much as we like to sort of demonize them, the utilities are staffed by clever folks doing their best that they can. But we do probably need to look at the model for how transmission and distribution are managed across these utilities. So I think we have a big role to play. Maybe the biggest one, though, is in terms of making consumers into prosumers. Like people don't understand how the energy system that they rely on works. So I think a big part of and you're doing your part for sure on this, Tim, but I think a big part of this is we need to become educators. We've seen a situation where folks have been able to control the narrative about energy with complete garbage about, wind turbines and such being these horrible things. And those of us who know better have been comparatively silent. And I think one of the things that we have to do better at is winning the hearts and minds of folks and educating people because we are representing energy resources that put money and resources back into the communities where those energy sources are located, by and large. We generate local benefits that folks should be not afraid to take advantage of because they've been misinformed about the technology and the risks.
Yeah, yeah. So it's, in a way, it's a rising tide, right? And it's floating all boats. The grid benefits when people install solar and batteries in their home or in their commercial
Mhm.
facility or at a utility scale. And right now, the way it works is the grid operator and the state PUC come together in some meaningful way. In Illinois, that takes the form of omnibus energy bills like Surja, which everybody's jumping up and down for joy about. And there is a second or third gold rush happening in Illinois now, much more around storage than solar, but the solar train is rolling. And and now we're going to install, I think, 3 gigawatts of batteries in the next 10 years or something like that. It's, in my opinion, it's not enough, but it's a lot more than we were going to do without Surja. So I'm grateful for Surja and all those stakeholders. And to some extent, we're leading the utilities by the nose and just saying, look, here we go, and it's going to work out for you. You will be fine. And we have to remember, we're going to triple the grid. We're going to triple the amount of electricity we use. And so if they're in the business of selling electrons, they're going to be fine, even though we will generate a bigger and bigger percentage of them with wind, solar, and then energy storage in the mix. All right, so we should probably shift gears a little bit for the last segment, though, Shawn, and talk about technology and fire code and electric code. You mentioned in the pre-show NFPA 855. What's going on with NFPA that energy developers and installers need to know about?
Yeah, no, it's a great question. So for those that don't know, NFPA 855 it was first published in 2020, and it's a standard for the installation of energy storage systems. It covers more than just batteries, but there's a lot in there about battery installations. And 855 has been incorporated largely into the model fire code. So if you live somewhere where you've had a fire code update in the last few years, probably some bit of 855 has made its way into your local fire code. And there's some really important stuff in there that I think communities should know about, but also developers and asset owners should know about. Because there's a lot more scrutiny, I think, than maybe people realize that goes into determining whether a battery system is going to be safe or not. So, in addition to requiring things like that the battery be listed to UL 9540, which is a very rigorous product listing standard that covers everything from how well the battery resists impact to how well it might resist large electrical discharges. You also have to go through a lot of fire testing processes. One of the things that really struck me in the reporting last year, Tim, was just how many communities had enacted moratoria or restrictions on the deployment of solar, wind, and or batteries. Something like 15% of the developable land in the US, I believe it was, is currently under some such restriction. And the major community opposition to batteries is fire safety. So, and I cover this quite a bit in the updated book that's coming out from ICC. But in short, one of the things that I discovered is that battery utility and commercial scale battery systems catch fire at a rate of about 0.3% per year, which happens to be about the same as a residential household. In other words, if you have 100 houses and 100 utility scale battery projects, over 10 years, you might expect that three of them would have some kind of fire event. But luckily we're learning a lot more about how to combat those fires. And so some of the very newsworthy battery fires we've seen in the past, if they were to happen again today, the outcome would be much different, much less impact, much less time spent on site fighting the fire. We've learned a lot. 855, though, has a new concept in it called related to large scale fire testing. Up until now, large-scale fire testing meant you would initiate thermal runaway in one cell, which is the process by which essentially the battery enters an irreversible reaction where heat builds up and it catching fire is a foregone conclusion, essentially. And you would see what happened. You'd measure how much heat was released, what gases were released, all these kinds of things. But the community, the industry, we rightfully pointed out that that's not necessarily the worst case. That's good for testing explosion risk and things like that. But fire risk is something else. They're often conflated, but fire risk and explosion risk in some cases are almost inversely related. So, in order to test for fire risk, the new standards are calling for essentially setting a battery container on fire and igniting all of the flammable gases as well. So you really are burning the whole container, and you're seeing how that impacts nearby surfaces. So you say, this is what tells you how far apart you can place things. And so the 855 is now calling for having both of those test results, so explosion and fire risk separately maintained. It's also requiring for active control of flammable gases. So instead of waiting for the pressure to build up and then having a passive system to, say, burst open and relieve the pressure in the container, systems complying with the new NFPA 855 standard will have to have an active ventilation system that keeps the flammable concentration below the level at which it becomes flammable. So if you're off-gassing and the system detects, say, a buildup of hydrogen gas, it'll immediately go into maximum ventilation mode, which is the complete opposite of how we handled that same situation, say, 6 or 7 years ago.
Hmm.
So again, we've come a long way, and I'm if your listeners aren't asleep by now, I'm shocked. But
Well, I want to point out, if you're interested in UL 9540 or UL 9548, I've covered this in depth in a series. Go to episode 243 with Ryan Mayfield and Zihan Yi. Dr. Yi is from CPS America, the three-phase string inverter and battery maker. Also, episode 300 with Joe DeBellis from a company called Firetrace that makes fire safety systems for these battery containers. And so there's lots of good content out there on 9540. But I am curious, when a lithium ion battery, let's say LFP, has a thermal runaway event, there's flavors of lithium ion, and LFP is, on the safer end of the spectrum, which is why, stationary storage developers like it. But if and when there is a thermal runaway, why is it that there's potentially flammable gases in the container then?
yeah, so when a cell begins to go into thermal runaway, the first gas that escapes is hydrogen, and then what comes shortly after the hydrogen is a mix of things like carbon monoxide and carbon dioxide, and a variety of things ranging from there can be a little bit of benzene in there. There can be all these horrifying things. I will say that it's important to bear in mind that you will get almost all the same stuff if you set your average house on fire. So it sounds bad when you know what all the gases are, but
Yeah,
unfortunately, anywhere where we use things like plastics, you're going to find the same stuff.
yeah.
So those they tend to be flammable at about a 7% concentration inside the battery container. And there's not a lot of free air in many containers. They're pretty well packed with batteries and electronics and such. So it doesn't take a lot of flammable gas to raise the overall concentration to 7%, at which point if there's an ignition source of some kind,
Mhm.
it can ignite. And so that's why the active ventilation systems will try to keep the concentration no higher than, say, 2 or 3%, because they're really
Sure.
seeking to keep that concentration way below that flammable limit.
Okay. And that also brings up one of my favorite episodes from last year. A gentleman named Matt Ward, who's president of Attica AG. They have developed a battery that is stored. Well, the modules are soaked in dielectric fluid, which is the fluid that's in transformers.
Yeah.
So it's a very fire resistant fluid. And this theoretically prevents the modules from catching fire. And he said that they had a very, very hard time meeting the UL testing standards because you have to actually get the battery to start burning in order to complete the test. And I'm not sure of how they got through that or if they're still in that process, but check out Etika. They're in the process of building a factory, I think in Pennsylvania. I don't know. Have you heard about Etika?
Only a little bit. Yeah, it's a really interesting technology. I've not looked at it super closely or used it on a project yet, but it's a really neat concept. Yeah, and that's the beauty of the industry. It's like there's so many creative approaches to solving these problems. Some of it's not very showy, right? A lot of it is impregnating separator materials inside the batteries with ceramic so that it's harder to penetrate the separator and create a short circuit. No one even knows that that's in there, but it's in there. And, every year we have these kinds of many quiet advancements within the technology itself, making it safer and safer. And then of course, we have the more dramatic stuff like what Atka's doing. So it's really neat to see the variety of approaches to tackling this.
I didn't catch that. Like who's doing?
I like Attica.
Oh, okay.
Yeah.
Got it. Yep. Yeah, it's a weird
Yep.
name. It's a Korean and or Taiwanese and German company that came together. I don't quite understand that, but anyway, I guess I'd love to wrap this up with a bow if we could make a few predictions for storage. We were talking in the pre-show about FIOC and the OBBB, and everybody wants to get as much ITC runway as possible on their projects. This is very important for facility owners, especially, and asset owners. But here we are in January of 26. There are still some uncertainties, but the onus is coming, right? That you will, if you want full ITC, you have to avoid FIOC on some percentage of the CapEx. But as we were also saying, there's a constant calculus that you have to do because you can buy super cheap, non-FIOC free batteries from China, and then the ITC doesn't matter. Or you can buy super expensive American-made product. And I don't know if there's a happy medium in between, but how do you see this landscape? And when you're working with your customers, how do you see the analysis coming out?
Yeah, so we have been looking into this for some of our clients who are trying to come to grips with the limited availability and relatively high cost of FIOC compliant storage products. And what we're seeing is in many cases it is cheaper to forego the ITC and purchase direct equipment from China without the tax credits. So you remember, let's say you have a 30% tax credit. First of all, you lose 4 or 5% in transaction costs alone because the ITC and tax equity is an incredibly expensive process to engage in. And then from there, if you're looking at a system that has a significantly higher marginal cost of say $80 or $90 a kilowatt hour, which is, kind of the marginal cost for FIOC compliance we've modeled in a number of cases, and you're looking at the DC block costing $125 per kilowatt hour, there's no math there that makes it work out that you can get your tax credits and have it make sense. So in some cases that's tough, but I think the bigger problem you're going to have is if you were to do that, if you were to go with Chinese sourced equipment, you run into a whole host of other issues that I think tie into the global escalation of relations between our two countries. You have, the Uyghur Forced Labor Protection Act, which is being enforced to a greater degree on batteries than it has in the past. You have the Lone Star Infrastructure Protection Act in Texas, which says you can't have any Chinese equipment interfacing directly with the ERCOT grid. Obviously we've seen what happened with folks like Huawei. So there's a growing concern, I think, that though you might be able to procure non-FIOC compliant equipment, forego the tax credits, and have that be cheaper, you might be almost forced down the more expensive path because taken together, there is just a growing difficulty in putting Chinese sourced equipment into, it's no longer necessarily a sure bet. You can drop it into any given project you're working on, regardless of how the economics come out. So the economics are one part of it, but the overall, I'd say that the atmospheric conditions around FEOC and what led to that coming into the OB3 in the first place, I think we're seeing them ripple elsewhere too. It really makes you have to think very carefully about what you're going to build, where you're going to get it from, and when. And as soon as OB3 hit the street, we saw a big contraction of the presence of the Chinese OEMs in the US in terms of reducing headcounts or canceling plans to expand headcounts, which was one of the many impacts of the OB3 in terms of our industry. But that means that you may be able to buy cheap Chinese battery equipment, but you also have to be very, very sure that there will be a partner there to service it and commission it and all that kind of thing when you get that far. So the purchase order is just the first step down the road. It's not the last. So I guess
Well
I would say
said.
there's a lot to consider.
Yes. And that is why we need experts like you in our midst and on our development teams. And I will wrap it up there. I'll say, please check out all of our content at cleanpowerhour.com. Tell a friend about the show. That's my only ask. I do this largely for you, energy professionals. I am not getting rich as a podcaster. I am grateful to my sponsors and to my customers. And you know who you are, and you hear the ads on the show for Chint Power Systems, my major sponsor. Super grateful. The show would not exist if it were not for Chint. And so check that out and tell a friend. And then, Shawn, how can our listeners find you and Camelot?
Yeah, absolutely. So we're pretty active on LinkedIn, or you can find us on our website and say hello at www.camelotenergygroup.com.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. With that, I'll say, let's grow solar and storage. I look forward to having you back when the dust settles on all of the IRS rules around batteries, hopefully later this year, Shawn.
Fingers crossed. Yeah, thanks so much,
Let's
Tim.
grow solar and storage. Take care, Shawn.
All right, take care.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.